Hello everyone. Today we are going to start with the first module of science and technology, and this is space technology. Now when you look at space technology, strictly speaking from your examination perspective, this is the most important module that we are going to cover. If you go back to past papers, whether your prelims examination or your mains examination, you will find that a large number of questions come from here. Every year, at least 2 to 3 questions are coming in the prelims examination, and every year in the mains examination, we do see that one question does come from here. Very often, we see that most of the times the questions that have come are a part of your basic understanding of space technology, which has been applied to current affairs. So that's why we'll try to learn how to apply the static areas to your current affairs as well. So prelims every year 2 or 3 questions, mains one question almost every year is being asked. There are hardly any year where you'll see that a question from space technology did not come. Now, when it comes to this module has been divided into 4 major sections. The first section that we have is about the universe. We learned the basics of formation of the universe, about dark energy and dark matter. Then we'll go on to some of the prelims related facts about some of the planets and about stars, etc. So this is what we are going to do in the first section. The second section is about space technology. So this is where we'll learn about how a satellite is launched, what is a satellite, what are different kinds of orbits, what is GSLV, what is PSLV, all these kind of things we'll have a look at in the second section. Then the third section will discuss briefly about ISRO, the organizational structure of ISRO, what is ISRO, what are the various roles that ISRO is performing. And then in the fourth section, we'll learn about some of the very important space missions, whether Indian or foreign, but we'll learn about them, and some of the outer space treaties. So this is how we are going to divide the entire module that you are going to learn. So first of all, let's start with the first section, and that is about the universe. Now, when we talk about the universe, first thing that comes to your mind is what exactly is the universe? How do we define the universe? And this is where you might get confused, because everything that you see in the night sky is a part of the universe. Everything actually that you see around is actually a part of universe. Whether you talk about me, you talk about yourself, you talk about anything that you have in your vicinity, each and everything is a part of the universe. The stars, the planets, the sun, the moon, everything that you see in the night sky is also a part of the universe. So, a question comes in our minds that how do we define the universe? What should be the definition of the universe? So, there is one very famous definition that was given by an author named Alexander Bolonkin. What he said was anything that exists, anything that has existed, and anything that will exist, everything is a part of the universe. Very simple, right? Anything that exists, anything that has existed, and anything that will exist is a part of the universe. And probably it sums up everything, right? Because everything that you see today is a part of the universe. Anything that you don't see and perhaps is getting born today is also a part of the universe. Something that existed, something that does not exist anymore, a star, for example, which has died, is also a part of the universe. So each and everything that might have existed, that might exist today, or something that may exist in future, everything is a part of the universe. So that's how you can define it in a very simple manner. You don't need to go much beyond that. Now, when we talk about the universe, what do we have in the universe? Very simple, we have two things. We have matter and we have energy. And these are two things which are interconvertible. There's a very famous equation, and I'm very sure that most of you know about this equation. E is equal to mc squared, right? You may or may not know what this equation means, but I'm very sure that you have come across this equation, an equation which was given by Albert Einstein. So what does he mean here? E here basically stands for energy. E stands for energy and m stands for mass. E stands for energy and m stands for mass. And when it comes to c, c is the speed of light. So this is how he had established a relation between energy and mass. So that's why when we say that what is there in the universe, a simple answer is matter and energy. Because matter can be converted into energy and energy can be converted into matter, right? Very simple. So matter can be converted into energy and energy can be converted into matter. Very simple. Let's say you have coal. You burn the coal, you get energy out of it, coal gets burned. So what happened? The matter that was there in the coal has converted into energy while it was burning. So everything in the universe is either matter or energy. Now, if somebody asks you, okay, matter and energy exist, fine enough, I understand that. But let's say somebody asks you that, okay, you are saying that the entire universe is composed of matter and energy. I completely understand that. But what is the composition? What kind of matter? What kind of energy? Then there is something that you have to understand, that when we talk about the composition of the universe, there are three major things in the universe: something which is called as dark energy, something which is called as dark matter, and the rest. So, dark energy, dark matter, and the rest. And as you can see in the diagram itself, approximately 70% of the universe is dark energy, approximately 25% is dark matter, and rest 5% is this. 0.3% of the rest is just stars, is just neutrinos. You don't need to worry about what is neutrinos, we'll have a separate discussion on them. 0.5% are stars. 0.17%, interestingly, are antimatter and electromagnetic radiation, and 0.03% heavy elements. So everything that you see, everything that you observe is basically a part of the rest. So first let's understand what is the rest, and then we'll go to what is energy. So first of all, let's try to understand what is the rest, and then we'll go to what is dark energy and what is dark matter. So when we talk about the rest is everything that you see, everything around you, all the stars, the sun, the moon, the night sky that you observe, all the plants, all the animals, everything on the earth, each and everything is a part of the rest. So, whatever you are seeing currently, everything that you are able to observe, even with the telescopes, is just 5% of the universe, approximately 5%. So, then comes a question, what is the rest of the 95%? And this is a big mystery. There are two terms that you have to understand here, one which is called as dark energy, and the second one which is called as dark matter. UPSC also has asked a couple of questions on dark energy and dark matter in the prelims examination. So, what is dark energy and what is dark matter? Let's try to understand this first. So, when we talk about dark energy, this picture becomes very, very important. What you see in this picture is that we are trying to depict the universe as it exists today. We start from the Big Bang. You might know that Big Bang is how the universe started. We'll have a discussion on what is Big Bang. So, from the start of the universe, we see that the expansion of the universe can be observed. The universe has been expanding, and this is an accelerated expansion. The expansion of the universe that we observe is an accelerated expansion. What is the meaning of accelerated expansion? It means that the expansion of the universe is accelerated. It is not uniform, it is not linear, it is expanding. And while the expansion is happening, it is accelerating while it expands. So let's say if it was not an accelerated expansion, then either you would see expansion happening like this, or maybe if it was, let's say, not expanding at all, it was uniform, it was linear, then in that case maybe you might have seen something like this. But what we observe is the expansion happening like this, just like a funnel. So that's why what the conclusion is, that there is an accelerated expansion of the universe. Now, what the scientists feel is that normal energies that we have, that cannot be responsible for something like this to happen. That there should be an extra amount of energy, an energy that is not known to man, and a kind of energy which is completely unknown to us, and this should be the driving force for this accelerated expansion. Because everything that we know of, everything that has been accounted for, those cannot explain why this expansion is happening. So this was a big mystery, and because of this being a mystery, they said that okay, there has to be another kind of energy, and this should be the energy which is causing the accelerated expansion of the universe. So if we know about the accelerated expansion of the universe, and we know that yes, we have observed that this is happening, then there should be something that explains it. And there is the concept of dark energy. This is where the concept of dark energy came into the picture. An unknown kind of energy, a hypothetical kind of energy that should exist, that should permeate all of the universe and should cause the accelerated expansion of the universe. So if you have to look at the standard definition as we see it, unknown form of energy which is hypothesized to permeate all of the space, tending to accelerate the expansion of the universe. So dark energy, that's why, is the most accepted hypothesis to explain the observations since the 1990s, indicating that the universe is expanding at an accelerated rate. So this is how the concept of dark energy came into the picture. That yes, there should be another kind of energy that is driving the accelerated expansion of the universe. And since we have not been able to establish this energy, since we don't know what kind of energy this is, whether it's a kinetic energy, it is a potential energy, what is the source of energy, is it nuclear in nature, is it solar in nature, is it electromagnetic in nature, we don't know. We don't know about the nature of this energy, and that's why it was named as dark energy. Dark because we don't know what kind of energy it is. So very interesting concept, and what we say is that approximately 70%, you will see that in some data, some sources, they will say 68%. So this is a fluctuating data according to various sources, whatever you might see. So 68 to 70% of the universe is just dark energy. A kind of energy which is not known, a kind of energy which does not interact with the normal matter, a kind of energy that should explain the accelerated expansion of the universe. So this is about dark energy. Then there's another concept, and that is the concept of dark matter. So when we talk about dark matter, again the word dark has been used. Why dark? Because it does not interact with the normal radiation. It does not interact with the normal observations that we make for all the other kinds of matter. So for example, most of the other matter that you have in the universe, they would reflect or absorb light. If not light, any of the electromagnetic waves. That doesn't happen for dark matter. What I mean is, for example, let's say you talk about anything that you see in and around. You know that, okay, if light falls on an object, that object will be visible. Correct? You are able to see this lecture. Why? Because there is a backlight in your tablet, and that's why you can see it. Why do you see everything around? Because there's light, and light lets you see. Your brain functions accordingly, the eyes send you the signals, and you are able to see that object. Similarly, to see anything, or not, it's not only about the humans, but to observe anything, we need these electromagnetic waves. It can be a visible light, it can be radio waves, it can be any kind of wave which is electromagnetic. So if there is a matter which is invisible to electromagnetic waves, so if there is a matter which is invisible to this electromagnetic wave, then in that case it will not be visible, will not be able to observe it. Thing is, the matter that you see, everything around, even if you don't see it, you are able to observe it. Why? Because this is something that has mass and it occupies space. A very simple definition of matter, correct? What is matter? Class 6th you might have studied. What is matter? Matter is anything that has mass and occupies space. Anything that has mass and occupies space will be called as matter. So most of the matter we can see because they have mass, and the light is reflected, and because the light is reflected or absorbed in some of the cases, you will be able to observe them. But dark matter does not show any of these signs. Dark matter does not interact with this kind of light. Dark matter does not interact with the electromagnetic waves at all. So that's why it should be completely different kind of a matter. Now the question is, how do we know that such a matter exists? We are saying that, okay, this is something different, does not interact with electromagnetic waves, whatever they mean. But how do we know all this? If it was invisible, how do we know it? The answer to it is gravity. When we talk about the gravitational effects of, let's say, anything that we observe, for example, if it's a galaxy that we are observing, so galaxy has a mass, right? There are millions of stars in the galaxies, millions of planets in the galaxies, other celestial bodies. Everything will make the whole galaxy massive, right? It will have some mass. The calculations that are done for this mass is different as compared to what we observe. The calculations show more mass, the observations show less mass. What does that mean? That there is a difference between the calculation and the observation. Calculation is much more, observation is very less. And it's not that there are very minute differences between these observations that we are making. There's a huge difference. Why? Because almost 80% of all the matter that you have today is dark matter. 80% of all the matter. If you have 100 grams of matter in the universe, 80 gram of that matter is just dark matter. So whatever we are able to observe, whatever we are able to see, all this is just 20% of all the matter that exists in the universe. So that's why even the calculations that are done for a given galaxy or a solar system, etc., there also the calculations are off chart. They observe much lesser, they calculate much more. And this is where the scientists thought that there should be something else. Then there was gravitational effects, that the gravitational effects of these kind of matter are quite observable. Although the matter is not observable, you don't see the matter, you don't observe the matter, but their effects are observable. Just think of an invisible man. If there was an invisible man here, I would not see him, but if the same man slaps me, I would definitely feel it. So I'm not able to observe it, I'm not able to see him, but at the same time I feel the effects. Same happens here, that we are not able to observe it. Yes, it shows in our calculation, we are not able to observe it, but we are able to get the gravitational effects of it. We are able to observe the gravitational effects of it. Things like gravitational lensing. We'll discuss about what is gravitational lensing separately also. But when we talk about gravitational lensing is a gravitational effect. Gravitational lensing is a gravitational effect. So that's why if gravitational lensing is being observed for a given galaxy, then there must be a matter, because it is having gravitational force. Gravitational force is always associated with mass. You have your own gravitational force because you have mass. Earth is able to sustain you because Earth has a large mass, and that's why gravitational force of the Earth exists. So there, whenever you have mass, there is gravitational force associated with it, and there are gravitational effects associated with it. So that's why the things like gravitational lensing that are observed for a given galaxy, it shows us that there should be some other matter. So what is dark matter? A mysterious non-luminous substance making up the vast majority of matter in the universe, and that's why it is also called as invisible matter. It is also called as invisible matter. Does not interact with baryonic matter. What is the meaning of baryonic? Simple matter, everyday matter, normal matter. For now, just understand that this is normal matter, nothing else. And it's completely invisible to light and other forms of electromagnetic radiation, making dark matter impossible to detect with current instruments. Scientists are confident that it exists because of the gravitational effects it appears to have on galaxies and galaxy clusters, and it influences large scale universe structure, formation of galaxies, and affects the cosmic microwave background. What is cosmic microwave background? Again, we'll come to it when we discuss Big Bang theory. So for now, what we know is there is dark energy, there is dark matter, and there is the rest. What is dark energy and what is dark matter, we discussed, right? So these are few of the things that you need to understand from here. A couple of questions we have seen in the prelims examination also coming, a very direct question that has come with respect to dark energy and dark matter.